university, we found a problem with our cooling fan system. So we came up with some ideas with this automated cooling system, especially in the warm seasons. In here, it's very hot and very uncomfortable. So we can't even focus on our studies. So when we go into libraries or study areas, there are some study places are already occupied. We can't find places with fans. So what if a fan can adjust the speed according to the distance to the person, and what if it can sense the temperature? So we introduce you the automated cooling fan system.
My name is Today I'll be going through the hardware components regarding this setup. Okay, so first of all, we will be using two 9-volt batteries connected in series to give an output voltage of 18 volts, and then we will be using a buck converter to step down that voltage into 12 volts because our fan is rated as 12 volts, and then along that we will be also using a pulse width modulator. So in order to vary the output voltage seen by the fan, as you can see by the wiring here. Okay, and then for our input we will be using as you can see, to generate signals we will be using a Raspberry Pi, and for our GPIO signals we are connecting our GPIO pins to our sensors in sensors. Okay, so for our sensors we will be using HCRC distance sensor, and as well as a PIR sensor, and then a DHT22 temperature sensor. Okay, first of all, and camera as well. And for the main issue here was, since the pins were usually accepts 3.3 voltage, so but in our distance sensor the echo pin usually outputs a 5 voltage. So to overcome that we used a potential divider circuit. So what we did was we used a 220 and a 470, and then I connected the echo pin to the middle, and then I got the desired 3.3, which I tested using a multimeter, and then I used a PIR sensor, so I connected it to a common ground, as you can see here, and then the VCC goes to a separate power supply, and then the data pin goes to a GPIO pin 23. Okay, and then finally we can say about you can see the DHT22 temperature sensor. So it's just a simple circuit. So the red wire here is the VCC, and then the yellow white one is the data pin. So in between I added a 10 kilo ohm pull-up resistor, and then we used two jumper wires to connect it back into the Raspberry Pi.
Hi everyone, I'm Prasanna. Okay. In this project we have planned to when a human comes in front of the system, it will automatically turn the fan on. So at first we had planned to build the system without a camera, so the motion sensor and distance sensor will detect whether there is any motion, and if the human comes then the fan will be turned on. So the problem we faced is we cannot directly say whether it's a human or not using only the motion sensor, because in the desk, if there's a cat or dog, it will automatically says to turn the fan on. So what we are doing is we use the camera and image processing system to detect whether there's a human or not. So the system will turn on only whether there is a human. So in the mobile app, we are using a IP webcam app. So what it actually do is it will collect the video and stream it in a certain IP address. So the Raspberry Pi board will use the OpenCV model to capture those videos and return it as a frame to the YOLO model. YOLO is a machine learning model that use it here to detect whether there is a human or not. So we are using YOLO version 8 model and nano model to detect the human presence, and it's also collect the information about whether how many humans are there, and with those information we are deciding to turn on the fan or change the speed of the fan. That's how our camera system works.
Hello everyone, I am Gitmin Ranasinghe and I will explain you how this whole setup works. So our idea was to build an automated fan. Obviously you know it. Now so we need inputs. So what are inputs? As Pramit explained you, we have different sensors and YOLO model. So the YOLO model was the only basic core concept to identify humans. Since the YOLO model runs every second, the Raspberry Pi heats up. So we came up with a clever solution. The solution was to use a motion sensor. So what does it do? Whenever this motion sensor picks up motion, so it sends a direct signal to the YOLO model to turn it on. So you will ask, what if a human stays in the room and there's no motion? Obviously, that's why we are using this system to check the room every 10 seconds, even if there is no motion detector. Then what does this distance sensor do? This distance sensor adjusts the fan speed according to the distance to the nearest human. And this temperature sensor also adjusts the temperature according to different temperature readings. So obviously we will show you some inputs and outputs we gained by running this model in the following video. And let's say if there are no humans in the room, so what would it do? If a human walks out, what would it do? Now I'll explain you about that. So if a human was in the room and left the room, this YOLO model will run few times and try to recognize humans. If there are no humans, it will eventually turn off. If there, let's say in the beginning, if it doesn't pick up any humans, the fan will obviously not turn on. How does it adjust the speed? Now it's a bit complex. We give this temperature sensor a minimum reading, which is 25 degrees Celsius, and a maximum temperature of 35 degrees Celsius, and we also gave it a maximum distance. Since we built a small model, not a huge industrial scale version, it actually has a small distance. We can level it up to build an actually industrial level whole setup. So this model will actually give you a clear understanding and a running working environment here, how it runs and how it works when humans are detected.